what I was saying. I'm going to say a lot of things that are slightly blasphemous that will offend a lot of people here, and then I will back them up. So that's always interesting, and we'll see where that goes. So first, I'm going to introduce myself. I wrote a couple of O'Reilly books. The Aerospike Up and Running one, I wrote. It just came out in November, so check it out. And I have about 28 years in data management. I've got an ISA Data Architect Foundation Fundamentals certification, and I have done pretty much everything in that time that you can possibly do in this industry, from writing data engineering software to implementing it, to documenting it, to teaching other people how it works, to competitive migrations, to product managing it, to product marketing it. So I kind of have an interesting perspective. In particular, I will talk about the trade desk use case at some point. And one of the guys that helped me write the Aerospike thing was a guy from the trade desk. And I used to work at Vertica. And trade desk was Vertica's biggest customer. And it was also Aerospike's biggest customer. So so I have some interesting perspectives on their capabilities. So, generative AI is the least important AI. I hate to say it, but I think this is an older version. I'm not sure how that's happened. We just copied it over. Realms of data science. Okay, so one thing I want to talk about is everybody here is hearing about generative AI. I won't talk a lot about that because there's about 25 other presentations on that. I also won't talk about governance, security, couple of other things. And again, because there's lots of people, those are important things, but lots of other people can talk about them. So you don't need me to talk about them too. I will talk to you a little bit about machine learning. So when people say AI nowadays, they mean generative AI. But generative AI is just this tiny little teeny piece of AI, and machine learning is much more mature and further along. And generative AI is still in the experimental stage. So probably what is more important to you right now is machine learning. Companies that use it consistently outperform companies that don't. And while it used to be kind of hard to get it into production, there are now some really good MLOps, model ops capabilities, and they're best practices, and follow them, and you can get it into production, and it's awesome. And it has a ton of use cases. I don't care what industry you're in, chances are your company could benefit from machine learning-based AI. Now, Gen AI is still, like I said, experimental. You need to think about it. Maybe in the future, like assign a little team to play around with it. But this you ought to be doing right now. Every time I swipe a card to make a payment, it's doing some machine learning to check for fraud, to keep track of what's my balance now, run the transaction, all of that in microseconds. And that is, or milliseconds. And that is a big use. Everything from smart grid to targeted marketing to real-time patient alerts. I mean, everything. It's like, is there anything this is not being used for? If you're in any industry, chances are you need to be using this. So, now this is a pet peeve. Concurrency matters. A lot of people, I got to ask you, how many people here have analytics software that their users line up and use it one at a time? Anybody? Yeah, I don't think so. Nobody does that. And yet, when you go to prove out analytics software to figure out whether or not it's going to work for you, what do? You test it one user at a time. See? She knows. And I, in particular, this is a POC I was involved with a couple of years ago, where a company, job search site, actually. By the way, I'm looking for a job. So it was a job search site, and it became very popular. And they were on Google Analytics, on the Google Cloud. And they discovered that once they got more than a certain number of concurrent customers hitting their site, Google Analytics fell over. It just couldn't handle that level of concurrency. So they started looking at a couple of other technologies, and they discovered that depending on what the concurrency level was, made a huge difference as to the performance in some technologies, and in other technologies it mattered very little. So the fact that they tested it is why they knew that, and they picked a technology that wasn't going to fall over on them again, or cost them a lot, or cause 30-second delays every time somebody did a query. So that was pretty cool. Yeah, this is definitely an earlier version of my presentation. Okay, well, we'll see how this worked. Oh yeah, that's way early. All right. I only copied one version over, so I'm not sure why that happened. All right, so this is supposed to say Hadoop, Iceberg, whatever multiple different kinds of S3, whatever kind of data lake you have right now, it can do certain things. It's quite useful for storing a lot of data, doing some data transformation, like the whole bronze, silver, gold. Are you guys familiar with the with that like medallion style of doing data integration? And it can do analytics for less than 10 people at a time. So if you have, say, a Spark data lake, and you have less than 10 people who need to do analytics, you're probably good. If you have more than 10 people, not so much. This is actually something that Ali Ghodsi has said himself is a problem. So it's not really good for analytics across your business. It's not good for giving you the performance that you thought it could. And here's one of the reasons. If I have a cluster and I need 50 machines to talk to each other, every time I can jump from one machine to the other, I have to go across the network, and there's a certain amount of delay. So the larger my cluster is, the more that delay adds up and matters. So again, here's a different POC that I went to a little while back. Somebody had 278 nodes, which that is not quite 278 nodes, but I got tired of drawing nodes, of Spark, and they were doing all their analytics on it, and they discovered that even when they added more nodes, they still didn't get better performance. At some point, they just reached a point of diminishing returns. And that was a big problem, so they got a different technology that could do the same thing at the same performance on 9 nodes. Why does that matter? What you need is to look for technologies that will use every bit of a node before it starts spread to another node. That scale up before you scale out is incredibly important because you will reach a point of diminishing returns if you just keep adding nodes. That is the worst possible way to scale up, is just adding more nodes. There are better ways to do it. Among other things, this meant it took them about $30 million to run for a month, just based on the infrastructure on Amazon. So these were some pretty large instances. And those 9 nodes were also the pretty large instances, about the same, and it cost them $1.2 million a month. So what that means is it was 25 times more expensive to run 278 nodes than to run 9, and to accomplish the same thing faster. But because I'm a tree-loving granola chick, what's really important to me is they were using 30 times the energy. So this is one of the things you're going to see with a lot of different types of technology, is the fewer nodes, the less energy it can use, the better the tech. And one of the things that has made a big difference right now is the change in computers themselves. So back when Hadoop was big, my laptop had 2 cores, maybe 4. Wow, beefy machine. Now you can regularly get an Amazon instance that has 48 cores and 96 virtual cores. That's normal. They just came out with a new server that has 196 cores. So if I can do 196 levels of parallelism, why do I need to have 50 machines if I can do it all on one machine and lose all of that parallelism. So it used to be trying to scale up was super expensive and difficult, and you had to buy a supercomputer to be able to get that scale-up capability, so scaling out was the right way to do it. Nowadays, scaling up is the right way to do it. It's becoming cheaper and cheaper and cheaper to buy a single powerful machine instead of 200 less powerful machines. And you get better performance, you get a lower cost of maintenance, you get a lot of things. So, a few years back, this was blasphemy, but clusters are not the best way to do anything now. They're good for storage, a few other things. They're not great for doing your analytics. Another aspect of this that has changed over time is that spinning disks are slow as Christmas. We already know that. That hasn't changed. Spinning disks, writing to a disk, reading out of a disk, that disk I/O is always the slowest point in any data analytics process. SSDs have changed that to a large extent because, I don't know if anybody remembers, I used to boot up a laptop, wait 5 minutes for it to boot up. Now, I turn it on, the thing is on and has recognized me and is ready to go within 5 seconds. Why? SSDs. That's the difference. And that speed is becoming more and more affordable over time, to the point where spinning disks and SSDs will reach parity in about another 5 years. To the point where it won't cost you any more to do SSDs than it would with spinning disks, at which point I suspect the spinning disks will go the way of the dodo. Unless you're trying to use software that doesn't work on SSDs. Now, if you are a software vendor and your software does not work on SSDs, fix that. Because very soon you will become obsolete or you'll become legacy like the guys that still have to have a mainframe to run. So, another big thing that's changing is that S3 is no longer an Amazon thing. So you can have a data lake like you have in S3 bucket on your Amazon, and you can have it on-prem. You can have it at a co-location center. If you have vast software, vast hardware, or scalability hardware, or Ceph, or whatever, a whole bunch of those guys do that. And MinIO is kind of cool because it's software that if you put it on anything, it turns it into S3 compatible hardware. So that means you can have a data lake anywhere you want it. You no longer have to have it on a specific cloud or anything. You can get your S3 compatible capability anywhere. Now, one of the other things that's super cool out there right now is Iceberg. So Iceberg took the concept of let's put Parquet on S3 and gave it a layer of abstraction and metadata so that I can now take Trino and hit it. I can take Spark and hit it. I can take Presto and hit it. I can take my different departments can all look at this data at the same time, no matter what they're using, whatever they like to use. Snowflake has it. Everything in the world can now read Iceberg. And that's very, very cool. Kafka. Kafka's your streaming data capability, right? And now it has the capability to flow right into Iceberg. And is that great? No, that sucks. Why? If you are trying to do that medallion data integration capability where you stream it in, you put it on a disk, and you do that bronze thing where everything in the world is there, and then you polish it a little, and now it's silver. You've read it off the disk, you did something with it, put it back on the disk. Now you read it off again, and you polish it a little bit more, and now it's perfect, and now it's gold. This is a batch-based process. This is a slow process. Kafka is a streaming capability, and you only get one chance to deal with streaming data and get a real-time answer. Once you have streamed it onto disk, it is now at rest, and you've lost your chance. So don't do that. If you need real-time processing, that's not the way to go. On the other hand, if you don't need real-time processing, that probably is a pretty awesome way to go. So another one, containerization, Kubernetes, all the things, yay. Okay, so Kubernetes and containerization in general, it has a really big advantage in that it can deploy anywhere. It can give you rolling upgrades so that you don't have to bring stuff down in order to make it function or bring it to the next level, that kind of thing. There's a lot of good reasons to do Kubernetes. But it is also hella complicated. You need some really smart people to make it work. There's certainly some job security. If you happen to be a DevOps engineer, that's a good thing. But it's also quite brittle. Once you've done everything in Kubernetes, trying to change something is very difficult. You have to go back and redo a lot of containerization and things like that. So it's got some disadvantages, and if you do not need it, then you probably shouldn't do it. But it also has some big advantages. So kind of balance, what your needs are, what your needs are not, and figure it out from there. Plus, there's a performance hit, which I'll talk about more. So what about auto-scaling? Auto-scaling is cool, right? It's great. It's an awesome thing. Or not, depending. Because it can be awesome. It is powerful like fire. Powerful and dangerous like fire. So this was a third-party benchmark. And if you look at this first section, 60 concurrent users, 250 terabytes of data, I'm doing my analytics. It takes about this much time for these 3 technologies. I'm thinking, there's not enough difference to matter. I'll pick whichever software I like the best, right? And then I find out that in the background, one of those technologies is auto-scaling like a big dog because that's the only way it can handle 60 concurrent users. And in fact, this benchmark was supposed to be done for 200 concurrent users, but the person doing it could not afford to auto-scale that high on that particular software, Snowflake. So we won't talk about what that was, but it auto-scales, and that is the only way that it can handle high concurrency. And that will hit you in the pocketbook big time. So be very careful. It can be career-endingly disastrous. You can use up your entire year's budget in a week and then get the bill and find out that, so that's not good. So there are disadvantages. So elastic autoscaling needs guardrails big time. You really should be able to say, only autoscale under these conditions. One of the things about autoscaling that's really cool is it can scale back down. So if I'm asleep, if it's Saturday and nobody's working, it can scale down to 0. And if you have it set to do that, that means you're not spending any money when you're not using the software. And that is, of course, a good idea. So cloud is not king. See, I'm seeing all these things that people are like, oh my God, surely cloud is king. Everyone knows cloud is king, right? So when cloud first came out, the big advantage that everybody saw was, I can replace my data center. I don't have to have a data center. I don't have to have the capital expense of going and buying all this hardware up front. I don't have to pay these guys to maintain it. I don't need a data center, right? So that's great. Except people figured out they could do the same thing with a co-location place, and the cloud was way expensive, a lot more expensive. And they were like, yeah, maybe this isn't such a good idea. And the cloud vendors were like, wait. What if you have highly variable workloads? What if you're a retailer and Black Friday comes along and you have 10 times your normal workload and then it spikes back down? Are you going to just have a data center with 90% of your servers sitting around looking decorative and not doing anything the rest of the year? No, cloud is great for that. So spiky workloads, that's a good thing. Somebody I was talking to earlier pointed out that he does work for a whole lot of very small companies. So if I have 100 small companies and they're all working for me and none of them have IT departments, one of the other advantages of the cloud is multi-tenancy. So I can put 100 of them on the same infrastructure, and that's a big advantage. So Cloud does have some advantages. Cost is not one of them. I have, in fact, seen a lot of people doing cloud repatriation. At this point, the last survey I saw said 80% of the companies that have taken all of their workloads to the cloud are now deciding which workloads to bring back on-prem, because the level of expense of the cloud is almost always higher. I have not, other than the guy who was managing 100 things and put them all together, I've not seen anybody who took their workload and went to the cloud and wasn't spending more money now. In some cases, orders of magnitude more money. Catch Media, that's a nice quote. I could rebuy the servers every 2 months based on what I'm spending on the cloud. Obviously, they went to a co-location capability. Here's another example where a very large telco that I will not name was using a technology, and they kind of like had it scattered all over the place. It's a big company. They had lots of, silos and stuff like that, and they were like, a new data architect came in, and he's like, I can build you guys a private cloud that will serve everybody in the company. It will not only do that, but make everybody happier, better performance. It'll work better. And instead of almost 17 million, I'll do it for less than 3. And, of course, his bosses were like, go for it, do it. He did. He did the cost-benefit analysis. He's like, see, I did it. And then someone took his CEO out golfing and told him that the cloud is cool. Everyone is going to the cloud. If you're not going to the cloud, you're being left behind. You should totally use our software on the cloud. And the data architect fought it and was not able to do it. So he stuck around long enough to get it all up on the cloud, do the cost-benefit analysis, and then he quit. Because fashion is the worst possible reason to go do anything technology-wise. Just because it's cool and everyone else is doing it, not a good reason. That's the worst. That is absolutely the reason you do not want to do that. Now, another thing that people don't think about with the cloud, everybody thought about with a classic data warehouse. Oh, lock-in, I'm stuck on Oracle forever because I have an Oracle warehouse. Okay, but now I'm going to go to Amazon and I'm going to use all their services. And oh yes, they have egress fees. And wait a minute, this sounds like lock-in, because it is. It's exactly what it is. If you use all the services on a particular cloud, if they have egress fees, you are locked in. It's exactly the same thing. They're not going to tell you that, but it's there. Yeah, this is pretty old. All right. Okay. So anyway, there is if you want to look at the QR code, that's an old, like a year or two worth of ago survey. But 78% of people were going to the cloud, yes. But most of them were doing hybrid for various reasons. One of them is, which I'm not even sure it's on there, but regulatory compliance. There are some regulations for certain industries that say you can't put your data in the public cloud, period. And therefore, it's out the door for you. Another thing that I have seen from a different survey, not that one, 80% of companies, or I think it's up to 90 maybe, 80, I think it's 80, conservatively 80, are multi-cloud nowadays, which means they have their data on Amazon and on Google and on Azure and who knows, Alibaba, some boutique. I saw someone was using Vulture. I'd never even heard of it. There's lots of clouds out there now, and people are using different ones for various reasons. It may be because you're an Azure shop, and then this guy over here is a Google shop, and he bought your company, and now half your company is Azure and half of it's Google. And now they have to talk to each other. And they both have egress fees, so when one goes to the other and the other goes, it costs you money. So there you go. So that's kind of a problem. On-premise object storage, I think I already talked about that. So deploying everywhere is key. So being able to take your things and move them to somewhere else is key. I have a mantra in my head that I think is something everyone should remember. You can say it with me. Desofu. Desofu. Think about that. Every time you do anything with your data architecture, it means don't screw over future you. Don't do something, don't make a decision now that in the future you will be kicking yourself for. Keep in mind that everything changes. A few years ago, the cloud was king. Everybody needs to go to the cloud. Yay! Now it's Gen AI. Yay, Gen AI. I've heard some folks that were so all in on Gen AI that they fired whole teams. And now they're hiring them back because Gen AI fell on its face, and they now need the people to come in and fix it. The way you were doing things 5 years ago, I guarantee it's not the way you do it now. 10 years ago, completely different. 15 years ago, completely different. So what happens 3 years from now, or 5 years from now, you're going to have to change a lot of it. So make everything as pluggable as possible. Keep yourself fast and loose. Don't get that locked in to one particular location. So Amazon services may look nice now, but they won't look so nice when you're trying to go somewhere else. Advantages of cloud: elasticity, spiky workloads, fast growth. If I'm in a little startup and I'm doubling every 6 months, I don't want to have a data center that doubles every 6 months. That would drive me crazy. Ease of use. Snowflake is super easy to use. Anybody can get on it. It's wonderful. That is a very nice thing. Reduced maintenance, you don't have to take care of it. I would add multi-tenancy. If you have a whole bunch of very small customers, good data is another good example of somebody who has that problem. And the multi-tenancy makes their lives a lot easier. Disadvantages: cost. Anytime that you think you are going to the cloud to save money, you are wrong. Please don't let them convince you of that. That is not accurate. I've never seen anybody that saved money by going to the cloud unless they had a whole lot of little guys that they were trying to put up. Watch for lock-in, watch for egress fees, and pay attention to your regulations. So, performance does not always matter. I've lost track of how many POCs I got into where all they looked at was performance. How fast are you? Doesn't really matter that much in a lot of cases. Sometimes it really does. But sometimes it really doesn't. Most times, it really doesn't. Why does it not matter? Why is everybody going to the cloud if it's slower? Which it is. Kubernetes is slower, the cloud is slower, everybody's going to Kubernetes in the cloud. Why? Because performance is really not that important. It's about as important as what comes out of the back end of that cow at times. Whether it does it in 30 seconds or a minute and a half, whether it does it in 30 milliseconds or 500 milliseconds. Just doesn't matter for most use cases. I don't care. Nor is cost savings, obviously, because we already talked about that. You're not going to save money by going to the cloud. So why are people doing it? Because fast enough is fast enough for a lot of workloads. Before you start thinking about how do I do real time at scale, think about if you need real time at scale. Because there's no point. It takes a lot of money, it takes a lot of time, it takes a lot of work. Don't do it if you don't have to. Skip it. Cheap enough is cheap enough. If what you need is that ease of use, democratization, more people doing more work faster is a lot of times worth it. And that's why a lot of people are going to the cloud. So, performance doesn't always matter, except when it does. And then it really does. So let's talk about that a little bit. So we talked about streaming data versus at-rest data. And similarly, real-time analytics is pretty much the same idea. If your data is in motion and you need a real-time response within, 300 milliseconds, 30 milliseconds, 20, whatever your SLA is, don't write it to Iceberg. Don't write it to anything. Keep it streaming. Keep your moving data moving and do your data transformation do your analytics while it's still streaming. Well, that's easier said than done. And God, that's a mess. I swear I cleaned that up, and the PDF will look better than that. I don't know why. I got the earlier version of this. So this workflow, though, was from a device manufacturer. Philips does MRI machines, CAT scanners, those kind of things. So you go to the hospital, you got a problem, you don't want the MRI machine to be down this week. Sorry, well, it doesn't work. We can't, figure out where that bullet lodged in your brain. They have predictive maintenance on their devices so that every single component phones home, tells them what's going on, and they can predict that this particular part is going to break and fix it before it breaks, so that they have closer and closer to 100% uptime. That is their goal, and they're getting pretty close to that. Of all the people that I have talked to since I got here, one guy needs this. His company builds those cherry pickers that pick people up and put them on so that they can work on high lines and things like that. It makes it big equipment, and they have the same thing. They have a telemetry that sends them information, and they use it for two things. One, they use the real-time capabilities to tell them what broke. They're not at the predictive thing yet, but they pack special packs so that the guy can take it with him to go fix the machine, and it has all the right parts, because he already knows this is what broke. Plus, if they accidentally drop somebody and they die, that's bad for business. So he needs that real-time information. He needs to know this is going to break. This is just now broke. Let me fix it. So the way that works is all that data streams in. It gets combined with historical data, and this is true of almost every machine learning capability. I think even you talk about real time and you think it's looking at real time. No, it's looking at data from the last 6 months. And it's combining that, and it's figuring out how does this pattern of this thing that's streaming in right now relate to something that happened 3 months ago. And that's how it actually figures things out. It does this data transformation where it combines all of this, all the systems of record from all the other things, all the data in the archive, explores, trains a model, and then in real time, it gives you alerts based on the models that you've just trained. So this data cannot stop moving at any point, or you're not going to get a real-time response. So, yeah, I took out a lot of this. This is a lot of the changes, there we go. The changes that happened at the trade desk over time. But this is where they ended up. Now, they have Snowflake and Databricks and Amazon and a bunch of other technology, but the main ones I know about are Vertica and Aerospike, so I talked about those. So essentially, for extremely low latency, for them, their transactions are 10 million ad auctions per second. And that has an SLA of 20 milliseconds. That's when you need real-time analytics capability. 20 milliseconds. Oh my gosh. That has to be fast. That has to go through immediately. So where does it train the models? Down there in Vertica is where it trains the models. Now, Vertica has a primary subcluster of about 125 nodes. They have 15 petabytes of data as of this was created. I think they're up to 18 now. But essentially, they are constantly ingesting because 10 million ad auctions per second generates a lot of data. So they're constantly pulling that in. They're constantly training machine learning models. They're feeding ad hoc BI queries as well. But they're also feeding that data into Aerospike, getting the trained models, and getting in real time information on who won the ad spot, who got the best bid on that, because that's what they do. That's their bread and butter. And then once a day, they spin up these 64 node clusters and generate 40,000 reports for every single customer that they have to tell them, how did your stuff do? And then they spend it back down because it's a lot of money to pay Amazon. So this is all on Amazon, right? Okay, yes, but they have customers that absolutely 100% detest Amazon and will not do business with them if their data is going on Amazon. So they have also pretty much the same architecture on Azure. And they also, because they have ridden through a really bad disaster in the past where like Amazon's entire thing was, data center was flooded, they have a hot backup on premises. Because it costs $1 million, millions of dollars if they're down for even a few seconds. So they don't want to do that. So, like I said, so that kind of gives you the idea. It's like, this is a big deal. If you are trying to do real time. Now, I probably have the older version of this. Yeah, I don't have half of my stuff. This is an older version. Yep, that's no good. It totally skips the best part. Let me see. I'll just speak to it. All right. So the data integration hub part, let's say that you are trying to do real time. You have streaming data. You are trying to do batch. You need to combine them two in order to accomplish this. You need to train your models. You need to apply the models. You need to do all this in real time. There's a certain amount of analytics that would be great if you could do in real time, like fraud detection. It's like if I swipe my card, I don't want to wait 5 minutes before my transaction goes through. If I'm at the 7-Eleven buying a snack, I don't want it to take that long. But I also don't want some random guy to be able to swipe, $1,000 in California and buy a car. Or $1,000 is a pretty cheap car. Anyway, you get the idea. It's like every single transaction has to be done in a very small amount. So how do I do that? How do I do streaming and batch? Well, historically, there's been 2 ways to do it. There's been the Lambda architecture, which splits the two and does the streaming up here with Flink and Kafka, Kinesis, whatever messaging system you've got, and it does all the real time, and it has a completely separate branch that does all the batch. Now, what's wrong with this? Well, the problem is right there, where it says data transformation, and it's pulling in real-time data, historical data from systems of record, active archive, everything in the world, third-party data, all of this stuff has to come together in order for you to train your models and get accuracy on your predictions and get your response quickly. So if I've got 2 different branches, that's not going to work because they got to combine. So the other one is the Lambda. I mean, that was the Lambda. The other one is the Kappa architecture. And the Kappa architecture treats everything as real time. Puts everything into a Kafka queue and says, use Flink to do which Flink is really hard to use and has a very limited data transformation capabilities, but it's all you got on streaming data. And we're going to put everything into the data stream, and the stream is going to be super long, like 6 months worth of, and I'm sure Confluent would love it if you did that, because they would get lots of your money, and they would be delighted. But it is not sensible when not everything you do has to be real time. Only certain amounts of your capabilities need to be real time. I did not need to, spin up 40,000 reports in less than 30 seconds. I had a day to do that. 6 hours is how long it took. So there's no reason for me to do that in real time and spend ungodly amounts. So what is the right answer? And the right answer is a data integration hub, which I swear I will give you illustrations for. I don't know why. The wrong version did not come up. C'est la vie. So what it is essentially all the data feeds into an in-memory data grid. Now, what an in-memory data grid is essentially a distributed way to keep data within RAM. So you can do it with lots of cores, and you can do it with lots of RAM on fewer machines, or you can do it, scale it out to more machines if you need to. And you have SSD for your historical archive. You would then, when the data ages out and you don't need it, you've done all your real-time capabilities, you can immediately feed that. You can do your data integration inside memory. You get your response in real time. You can archive your data in, I would recommend Iceberg, but I mean, it doesn't matter. I found a diagram on it from Gigaspaces, and they use Oracle and mainframes, which I think is kind of crazy, but okay, if that's your jam. And that gives you the capability to then, once it's in Iceberg, to do whatever analytics other departments want to do, and in the meantime, you've done your real-time capabilities that you need. So the final takeaway is at least didn't change much, except for that. I got rid of that. Okay, so embrace disruptions, because the way you did things 5 years ago is not the same as now. Everything changes. But don't jump too fast into unproven technology. If I had jumped 5 years into machine learning, I would have regretted it, because most of the people who were trying to do it back then were failing, and were spending stupid amounts of money on things that didn't work. I think right now, everybody's doing that with Gen AI. So give it a minute. Let it settle. Understand the capabilities before you embrace it. Don't grab it until you are sure what it will do for you. Consider open technologies like Iceberg, multiple technologies, multiple deployment options, make everything so that you can deploy it where you need it, and you can pull it out and replace it with something else if you need to. Use analytics to innovate. That's an obvious one. And track your value. A lot of people don't know that the cloud is costing them more because they didn't track it. They haven't paid attention. And the big thing, DeSofu. Always remember that. Don't do anything now that you will regret later, and that will bite you in the butt in the future. So I think I was optimistic. I think I had time for Q&A, but who knows? Anybody got questions? I said a lot of crazy stuff. I know. All right.
Well, thank you, Paige.
All right.